Hi there. My name is Marta Fernandez, and I'm the Executive Director at RMIT Europe, the university's hub in Barcelona. RMIT is a global university, but we are proud to have been founded on the land of the Wurundjeri people of the Kulin Nations, the Aboriginal traditional owners of Melbourne. Whenever we meet in Melbourne, we say welcome in the Wurundjeri language and acknowledge the traditional owners of the land and their elders past and present. So in that spirit, Wominjeka, welcome. Today's webinar will explore the opportunities, challenges, and future vision of using space data for industrial innovation. We're very pleased to welcome speakers from the SmartSat CRC, the Australian Space Agency, the European Space Agency, and INDRA. As we go along, please feel free to add your comments and questions in the Q&A and give the ones you most like answered a like, and we'll try to cover as many of these as possible during the speaker Q&A. And now I would like to hand over to Professor Monica Wachowicz, who will be facilitating today's event. Monica is the Associate Dean of Geospatial Science at RMIT University, as well as Cisco Chair in Big Data. She's a world-renowned expert in geospatial data science with a unique multidisciplinary background in geomatics engineering, geography, and computer science. Monica has collaborated in research projects with many high-tech companies such as IBM, Cisco, Orange Communications, ESRI, and Siemens, as well as academics from the US, Canada, Australia, and Europe. Over to you, Monica.
Thank you, Marta, and welcome everyone. Omenjika. There has never been a more exciting time to be part of the space community, forging R&D collaborations and developing strategies for exploring what capabilities and technologies we must have in place to bring endless possibilities for knowledge development, space exploration, and commercial ventures. Next slide, please. Future space technologies will rely heavily on robotics and AI because in order to assist humans in space as well as here on Earth, we researchers, we hope that robots will be able to perform maintenance and repairs on space stations, meanwhile helping scientists with data collection and analysis, changing the current landscape, changing the current research ways that we are doing today, as more nimble companies will be exploring faster innovation methods. Data collected in space will continue to increase in value over the next decade. And much of the data collected will be analyzed by edge analytics in orbit to reduce the volume of data that needs to be analyzed and also to be transmitted to Earth. We will have a greater understanding than ever before about our planet. It's very exciting. Next slide, please. In 2030, we expect to see the rapid uptake and use of space data by everyday people. Our vision is that space data will become a regular commodity where anybody will have access to it. It's going to be like we are currently have access to the internet on your phones. Instead of spending 10 to 15 years developing huge and complex platforms, innovators are already deploying CubeSats and small-scale satellites that are generating more data to input into our new streaming analytic platforms. We expect that the space data will be prolific, although it will provide little value on its own. Companies will only find real value in generating and selling actionable insights from space data if they collect and intersect with other terrestrial sources. Space and terrestrial data, they work together, and they have to be together, analyzed together in order to help identify and drive new business opportunities and models across many sectors of our society, including, of course, learning and education, but also art and culture, economics, business, health and wellness, food, water, environment. The opportunities are endless. Next slide, please. This webinar is one of the many steps that RMIT is taking to strengthen the collaboration between Europe and Australia. The Geospatial Science Group at RMIT is one of the leading research groups in Australia, and through RMIT Europe, we are eligible to be partners in research projects within the Horizon Europe framework. We are now looking for Australian, European, and international partnerships, which will play an important role in the transition towards digital and green economies. If you want to know more about it, just contact me or RMIT Europe. Our speakers today are sharing their visions and experience in the space industry in Europe and Australia. Nothing what we'll be discussing here today is beyond our reach and capabilities. I hope by the end of this webinar, you will recognize that there is a role for all to play in the advancement of space, whether you are a student, an entrepreneur, or a scientist, or anyone else. So I'm very excited to have this opportunity and having all of you today to listen to these wonderful speakers that we have here today. So joining me now is Peter Woodgate. Peter is chair of the SmartSat Cooperative Research Center. He's also the chair of the 2030 Space and Spatial Industries Growth Roadmap, co-chair of the Australian government's Space Cross-Sector Interest Group, and he also the chair of the Australian Urban Research Infrastructure Network. He's currently a member of the Australian Space Agency Industry Leaders Forum and a board member of Geoscape Australia. Peter also served as a CEO of the Australia and New Zealand Cooperative Research Centre for Spatial Information. Over to you, Peter.
Thank you very much for that wonderful welcome, Monica. And I'd also like to thank Marta and acknowledge the behind-the-scenes great work of Karen and Ines as well. I'd also like to acknowledge the traditional owners and First Nations of the lands on which we're all meeting today across the world. It's a great privilege and pleasure, everyone, to be with you this morning and this evening, wherever you might be. And I'd like to just spend a few moments talking about the work of the SmartSat Cooperative Research Centre. If we could turn to the next slide, thanks. So SmartSat was set up 2 years ago by the Australian government. It's part of the Cooperative Research Centres program, which has been running for 30 years now in Australia. And SmartSat has over 120 partners. So it's part funded by the Commonwealth Government of Australia and the other parts by its partners. So 31 companies, including some very big international companies, 22 research partners, most of them are universities, but CSIRO and the Defence Science Technology Organisation, and 60 startups that are new to the industry in Australia. We've got a starting budget allocation of $245 million, which includes the cash and the in-kind. And that's the ecosystem that is now SmartSat, all those lovely logos that we've got. Thank you, Monica. Next slide. So SmartSat has chosen with its partners 5 primary programs, and they're the verticals that we've got there. If I was to summarise them, on the left, we've got telecommunications, focus on satellites. In the middle, advanced systems and sensors, and on the right-hand side, Earth observation. Cutting across all of these are some critical enabling technologies, and as Monica has mentioned, artificial intelligence, the need for improved security and resilience, and space governance. And all of these are oriented to mission-focused outcomes. That is, delivering the really high-quality information products that are needed to tackle the big challenges. Challenges like disaster response, telecommunications into remote and rural areas, and managing critical resources like water. Next slide, thanks, Monica. So what is the future of sensor technology? And I've listed a number of key emerging opportunities inside the space sector here. Some of them are well known to us, like miniaturization and multiple sensors on platforms. Artificial intelligence onboard analytics is emerging for us, and it will be very big over the next decade and beyond. That is, doing analytics on board. And that gives us the ability to rapidly increase the processing capabilities and delivery of the high quality information product to the end user where they need it, when they need it. The ability to transfer data and high quality information products in space from one satellite to another with pointable antennas is a critical new capability that we're looking at developing. And that enables us to have this persistent telecommunications coverage from sun-synchronous satellites operating in multiple swarms. And then, of course, the data integration on the ground, the vast amount of data that's been collected that can be augmented and value added by the space-based information. This challenge drives us into the digital twin era, and there are so many issues that we need to solve there in order to get that value added information product really working for us. Next slide, thanks, Monica. So the question of how cybersecurity can accelerate space, I want to share with you an initiative in Australia that sits under the Critical Infrastructure Advisory Council. And that is, Australia has a recognised series of critical infrastructure areas, and I've listed them there. They're the traditional ones. Space is the new one, and in fact, space is a key enabling critical technology for the integrity and resilience of all of those. So Australia is about to embark on a detailed analysis of how the supply chains that give integrity to those critical infrastructure areas there are dependent upon space-based assets and the information systems that they also support. So this will be a full risk-based analysis using the International Risk Management Standard 31,000/2018. And out of it will come a whole series of new initiatives to make our critical infrastructure far more robust and to cement the role of space and space assets in ensuring the integrity of those assets, bringing them much closer together. Next slide, thanks, Monica. So we have critical skills gaps, and earlier this year, together with AUD's Australian Space Agency, SmartSat published an analysis of the skills gap shortages in Australia. We identified 319 critical skills for space and spatial operating in the Australian context, and developed that as a taxonomy, which is the first time anywhere in the world that it's been organised in a systematic way that way. Our analysis of about 100 companies showed that we're short of those skill sets in virtually all of those areas. So the next step will be for us to map a course through the tertiary education providers to identify where we can uplift the pipeline over the next decade to overcome these skills gaps. And that will include micro-credentialing as well as traditional degrees and postgraduate work. Thanks, Monica. Next slide. So what are the big growth challenges for Australia? And I've noted the first one is establishing our fundamental backbone of capabilities, launch facilities, high-speed, ubiquitous and persistent broadband coverage, and precision satellite positioning capabilities at centimetre accuracy, again, wall to wall for the nation. Publishing for our industry where the emerging growth markets are both domestically and internationally will help them, particularly the SMEs and the startups that really don't have the ability to do those analytics for themselves. We want to overcome the skills gap shortage. That'll be critical, otherwise that will be a persistent brake on our ability to grow more quickly. We need to bring into our space ecosystem in Australia, because our space heritage is still relatively new, the entrepreneurial skills from established industries that we can help leverage back into space and therefore absorb the experience, knowledge that they've got and get that into our new bunch of entrepreneurs in Australia. And we want to make Australia an attractive destination for investment capital. And that means that we want to de-risk the investments by providing much more information about the activities and the potential of the companies that they'll be investing in. Next slide, thanks, Monica. So the importance, and this is my final slide, of strengthening the collaboration between Europe and Australia. We know what Europe has got. It's got a wonderful and deep space heritage and many high quality universities and great research and some beautifully established multinational companies. So Australia, on the other hand, has a very strong desire to lift its space heritage as quickly as it possibly can. We have a large number of universities, at least 25, who are active in space research. And of course, we've got CSIRO and we've got the Department of Defence, who are also very active in space research. And we bring Southern Hemisphere space access. We absolutely recognise that to do anything effective in space, it has to be part of a global partnership. We are so fortunate to be able to partner with so many of our great colleagues in Europe, and that will be of great benefit, we hope, to both Europe and ourselves. Thank you.
Thank you, Peter. Thank you, Peter. We are now going to hear from Aude Vignel, Chief Technology Officer of the Australian Space Agency. She's a space and aeronautic engineer who started her career at the European Space Agency and has now more than 30 years of experience in delivering large and complex engineering programs, embracing the introduction of new technology in the telecommunication, space, and media industries. Aude has contributed to the Australian space capability through white papers, events, conferences with the flourishing startup community in Australia and promotion for women in space and engineering at universities. Over to you, Aude.
Thank you very much, Monica. Like Peter, I would like to acknowledge the traditional owners of the land from which I speak today and pay my respect to the elders, past, present, and future. And thank you, Marta, Monica, and Peter for great words. I will try not to repeat your strong message because I really echo every word you just say, how space is important in our day-to-day life. And the first statement you made, Monica, about data, space is a lot about data. So very, very good to see we're all aligned there. Before I go to my first slides, for those who don't know, the agency is still quite young. We were created the 1st of July 2018. And what we did before trying to do everything and anything, we really took the time to choose the areas where we thought Australia had a great opportunity to grow. The KPI of the agency are very clear. We need to create 20,000 jobs in the next decade and triple the size of the space industry. So everything we do every single day is, what am I doing? Is it gonna help creating this 20,000 job and growing the industry? So we published in April 2019 our national space strategy. where we highlighted 7 areas of priorities where we want to focus our attention, our investment, and our work, because we think that we have a big chance there. And for each of these 7 priorities, my team is now busy writing a technical roadmap. So a very detailed roadmap on how we're going to proceed to grow the industry and create jobs in each of these areas. The methodology we used, and I will refer to one of your slides, Peter, where you highlighted all the participants of the SmartSat CRC. As you can see, we have quite a vibrant community in space in Australia. So that's the first thing we did when we started the roadmap exercise. Where is our capability today? Where are our strengths? How can we be competitive and how can we be comparative? So we start with this, and then we project ourselves in 10 years' time, and we are formulating clear vision and ambitions, and we know that that's where we want to be in 10 years' time. And then from where we are today to where we want to be in 10 years' time, we are driving pathways. And if you have the chance of looking at some of our roadmap, you'll see there is a beautiful fold-out in the middle of them with where we are now, where we want to be in 10 years' time, and steps to achieve this vision. So we've done a couple of roadmaps and some are to come, but that's to give you a bit of methodology. And when we do this development of roadmap, we realize that there are some cross services and cross technologies that touch all this roadmap. And the first one that really was obvious for all of us was data. Data is across absolutely each of these 7 areas. So this is what I would like to use this 8 minutes left that I have, just to give you a bit of an example in each of these 7 areas, how data is very important. I'll go randomly. I'll start with access to space, so bottom right. In access to space, an example is when you launch a rocket. If the launch doesn't go well, because space is hard and sometimes it fails, and that's okay. It's a risky business and you have to accept failure. You need to abort a launch. And we are now looking into systems where the rocket can abort automatically. So you don't have to press the red button anymore. And it's all because you have all this sensor and AI software inside the rocket that can take that decision for you with looking at the safety corridors and all the criteria that you can input. That's just one example. Robotic and automation. So as you may know, so first of all, access to space is a priority because you can see in Australia the land that we have and where we are. There is definitely an opportunity here to launch from Australia. Robotic and automation, this is about our expertise that we have developed with our mining industry. We can remote manage activities and operations that are far away from the operation center, and we do it very safely. And it's evident that you can translate the skills and expertise into space, because before we live on the moon, we're going to have to build all the moon base and all this infrastructure by robots remotely. So that is a need that is quite clear, and an opportunity for Australia that is quite clear. And as you've highlighted, Monica, to drive this robot and to have automation, you need a lot of data provided by a lot of sensors. You need to be able to integrate all that so that the automation comes from the robot making the decision itself, from data that it receives and from algorithm that it has programmed. So data is very, very essential and crucial in that area. Leapfrog R&D, this was a bucket where we said, we may not be aware of everything Australia can offer. So let's look into what we do in R&D. And if we see that there is a capability there, we will develop a specific roadmap for it. And it turns out that in space, medicine and life science, Australia has a lot to offer. And here again, when you think about how to sustain humans when they explore space, you need to have a lot of sensors and a lot of data to make sure that the environment they are operating into is safe for them. And you want to see how they react. You want to be able to say, oh, my astronaut is starting to be distressed here, I need to do something. So again, lots of sensor, lots of data to monitor, to integrate so you can take decision. Position, navigation and timing. Again, Australia, when you look at the land mass that we have, this is a very important aspect in our day-to-day life. And here the opportunity is we have a project to increase the accuracy of positioning down to 3 centimeters in urban area. You all know the application we have in our phone because of GPS data. I mean, you can even have your food delivered at home, and that's all based on GPS data. You imagine if we can increase the accuracy to 3 centimeters for automatic vehicle and all that. I mean, the applications are endless. And again, that's thanks to managing this data, integrating this data. I'm jumping to communication because in some way, again, because of the land of Australia, but also because we are looking at the Southern Hemisphere, we are actually the one supporting all the deep space mission. Like Voyager is tracked from Tinbilla in Canberra that CSIRO is operating, and we are the only station to do that. We're also looking into the next bandwidth that we can use to have more bandwidth because there are more and more data. When we go back to the moon, we don't want a black fuzzy picture. We want surround sound and 16K resolution. We want good picture. That requires a lot of data. So we're looking to optical, and we have a lot of blue skies. So it's evident for us to look into optical communication, and that's just transferring data from one point to the other. I'm going to Earth observation now. It's important to note that Australia doesn't own any space assets to date, operational one. We launched CubeSat, but they are more for science. At this stage, nothing operational. But we are acquiring EO data from Landsat and Sentinel, and have done so for 40 years. So we have developed an expertise and a niche skills in aggregating data from different formats and making sure we're curating them, we aggregate them, and we are develop that more and more. And I was mentioning the application you have on your phone. I believe EO is going through a revolution that's going to be as big as the GPS revolution. And there is a company in Australia called Arlula. They have launched a beta testing software, but it's an application on your phone, and you can say, I want a picture from a satellite from where I live, and it would just give you all the options that you have, free data, or you can buy data depending on the resolution you want, or depending if you want optical or in ER, IR, or whatever type of sensor you want. And I think this is going to grow and explode. And again, it's all about data. And last but not least, space situational awareness. I'm going to try to be short because this is one of my passion. If you remember, before 1957, there was nothing in orbit around the Earth. And you can watch on YouTube, there are some fast tracking video from 1957 before Sputnik was launched, and where we had one satellite in orbit, to today, where we have tons of satellites in orbit, and only 17,000 of them can be tracked, or 20,000 of them can be tracked. Only half of that are operational satellites. The rest are dead satellites. And then we have fragments of previous collision. You have flint of paint that are less than 1 millimeter thick, and they're traveling at 7 kilometers a second. And if that enters in collision with your satellite, it can just damage it. And you may have heard last weekend, ESA reported they had to move Sentinel-2B to avoid a collision. Before, it was very rare that you had to maneuver your satellite to avoid collisions. So this is becoming a very big problem. And space situational awareness is like an emergency domain that we need to take care of. And again, Australia has a big role to play here because we are looking at southern sky, and because we can aggregate this data because of our EO experience, and we can produce products that allows you to be informed of collision alert and to be able to say, okay, I need to move my satellite that way or that way. So this is just a quick example on how space data are important, to such a point that we have a few programs going on in the agency, and one of them is to develop a data center with data analysts that are specialized in space data, and that facility is called ASDAF, Australian Space Data Analysis Facility in Perth, hosted by CSIRO, and we want to develop a lot of competition and challenge to see how we can, with SSA data and Earth observation data, how we can unlock products and services, because as I said, I think this is the area of the future. And I'll stop there and looking forward to the rest of the presentation and the questions. Thank you.
Thanks very much, Ad. Our third speaker is Felipe Villalobos, who is a data analytics engineer working with the European Space Agency. Felipe works on Aspire with ESA, part of ESA Space Solutions, a non-equity funding program for SMEs that link their innovations to the United Nations Sustainable Development Goals and to space technologies and data. He graduated from the University of Bristol in 2016 and has previously worked at Elsevier and Sainsbury's, helping these organizations build and scale their platforms to an ever-increasing demand for data and its democratization. Over to you, Felipe.
Perfect. Hi, everyone. Thanks, Monica, for the introduction. It's a great pleasure for me to speak on this panel with these other wonderful people. But before we start, let me say that public speaking has never been a forte for me, so I hope everyone can hear me clearly and that I don't talk too fast. And secondly, but important to mention, that these views are my own and may not be representative of the European Space Agency. Okay, with that warning and disclaimer out of the way, we can move on to the next slide. Perfect, thank you. So I was asked to present on what the skill demands for the next generation of data analysts, scientists, and engineers could be, and to talk about my personal journey as to how I got to where I am, as I think there are quite a few undergrads and postgrads here potentially looking for their first jobs. I wanted to start with what I currently work on so you can understand a little about me and what I do first. So I work for the European Space Agency, or ESA for short. For those of you who haven't heard of us, ESA is an intergovernmental organization that dedicates itself to the development of Europe's space capabilities. More specifically, I work in ESA Space Solutions, where the rest of ESA is looking at the stars. The work we do is more grounded. To be brief, ESA gets money from all these member states, and a portion of that is reserved for reinvestment into space-enabled businesses that belong to our member states. I believe it's the largest, if not one of the largest, space-focused venture support networks. So the last stats I saw was somewhere along the lines of working with over 2,000 businesses and almost 400 million euros deployed. So ESA has a few avenues of deploying this money for funding. There are demonstration projects, feasibility studies, open competitions, etc. But I'm not going to go into too much detail there, but what you should know is that these are often fund very specific businesses, SMEs, industries that fit the description of that specific competition. And they can also be generally just super slow when it comes to awarding the funding, because intergovernmental there's a lot of bureaucracy. So I help manage a pilot non-equity grant funding program designed to be a new avenue of funding called Aspire with ESA. Aspire aims to open up the pool of potential SMEs that ESA can fund for a single unified goal by looking for businesses that can contribute to the UN's Sustainable Development Goals. These are 17 goals designed by the UN that cover topics like reducing poverty, affordable and clean energy, sustainable cities, climate change, so big range, and that have the other goal that Aspire has is that they also obviously have to match ESA's overarching goal of funding space-enabled businesses. So they have to be using space technologies or satellite data. You can see in the slide, in fact, that these could be that they're using EO data, satellite navigation, SATCOM, or maybe even just like using ESA pattern. Because these are the main entry requirements for Aspire, we can find and help businesses from a wide range of industries, which you can also see in the slide. It means that it's nice and surprising. Oh, sorry, go back the slide. It's nice and surprising to see the diversity we get. So, I mean, we can even find like fintech, which you wouldn't believe would be using space data or space technologies, but yeah, you can find them. So we have these two wide entry requirements, which from the outside are what's visible, but internally we're also trying to make big changes. We're using the opportunity to make managing Aspire much easier by automating a lot of the systems, processes, and reports that are needed to run a program like this, while improving the speed that things get done and contracts awarded. Testing new technologies, looking for ways to add more value to the business. This effort to increase automation is the real reason why I work on this program. So as you'll see shortly, my background is or was purely technical. So next slide, please. Thank you. So this slide kind of highlights my career path from university to now, which I realize is actually quite brief. It hasn't felt like that, I'll tell you that. I studied electrical and electronic engineering and graduated from my master's in 2016. Then I took a brief siesta, I'll say, and joined my first role in Cisco, which was a consulting company and systems on chips, or SoCs. That was more relevant to my degree than what I do now. But at that job, I learned Python and kind of fell in love with data when we started looking at how these chips performed on like a big scale and having to do these dashboarding to see whether they were meeting the specifications that they had designed. Then I moved on to Elsevier, which was, is the world's largest company for scientific research. I had never heard of it, but as it turns out, it was. I started working there as a software engineer and slowly started transitioning to data, which exposed me to quite a lot, actually. I learned SQL there. I learned my first cloud tool, AWS, or Amazon Web Services, for those who know of it. I learned Spark. And started learning machine learning and kind of a lot of other tools for my toolkit. One highlight there, I think, was doing customer matching. So I was using customer and product data there, and we did customer matching based on Elsevier has all these different products, which they had loads of different customer force. They had universities, governments, sometimes hospitals. And they didn't know who was buying what, so they would have to match and master this data in a certain platform. So we used ML to match this data. Then I briefly joined Sainsbury's on logistics data last year, and there I learned infrastructure as a service and Kafka, which is a real-time data streaming tool. And now I've moved on to ESA, working on things that I never believed were possible in my skill set. What I wanted to highlight here is that there isn't really a defined path. I've been shifting my skill sets and responsibilities throughout my career. Just because you didn't study the relevant subject shouldn't stop you from pursuing your goals. You have to consider where you want to be and think about how can I get there. Whether learning something new through self-teaching, is it accreditations you need, or is it work experience that you need in a specific subject, and then to pursue that relentlessly. So I want to show you the skills I've had to pick up and kind of believe what I need will be for the foreseeable future. Thank you. So this brings us back to the original question I was asked. What are the skills and demands for the next generation of professionals? I think the current technology landscape is huge, and especially in this industry, in the kind of data side of things, it's constantly evolving. There are countless tools, languages, and libraries that exist and that are being released. It feels like we're in that exponential curve, and we're moving faster than ever before. What this means is that the new generation and the current generation are going to have to be more adaptable than ever before. I don't believe you can pick a certain language or tool, learn it, and expect to become a deep specialist and then not have to learn anything else. Especially because requirements for businesses are kind of ever increasing because there's this ever increasing demand. This means that they often can't rely on the technology stack they use to stay the same. They need the most performant tools to ensure that their businesses can scale to this increasing demand. The most recent FANG businesses, Facebook, Apple, Netflix, Google, have been super successful at scaling because of this reason, especially because of their, the newfound reliance on cloud-based tools or solutions. So I wanted to show some of the skills I had to pick up along the way, but when I look at this image, I wonder how different it will be in 5 years, 10 years, 20 years in the future. When putting this together, I realized that university may not have taught me the exact skills. In fact, none of these I learned at university, but it gave me the soft skills I needed to kind of be agile and adaptable. I'm realizing my time's running out, so I'll keep this brief here now. But there's a huge wide range of skill sets. You obviously have your basic programming languages where you might start to learn ML libraries. I didn't even put the ML libraries there, but there are a countless number. You need SQL, containerization skills is what I've been seeing a lot of in the industry lately, which is kind of making these small independent bits of logic, CI/CD and deployment tools to keep like these processes to deploy production software automatic. Cloud-based tools, which there's now great competition for. You see Amazon competing, Google competing, and Microsoft competing to make the best cloud platform. And then dashboarding tools where you see Tableau, Looker, and Power BI, Microsoft. So it's super interesting. Next slide, we'll close it. But that's me. Hopefully that's kind of engaged people and wants to brought some questions. But yeah, feel free to add me on LinkedIn and send me a question. Thank you.
Thank you, Felipe. Our final speaker before we move to the Q&A, and please do keep your questions coming, is Emilio José Viedma. Emilio works as the Space Business Development Manager at Indra, where he focuses on the European institutional market. Based in Madrid, his career spans from 25 years with Indra, holding various positions in space engineering and business development fields. Emilio is a telecommunications engineer specializing in RFS systems from the Polytechnic University of Madrid and gained his MBA in 2001. Over to you, Emilio.
Thank you, Monica. Hi, everyone. My name is Emilio Viedma, and I work for a company, Indra. Indra is a Spanish company, a technological company that is present all over the world. We have more than 40,000 employees, and we do a lot of things, but more specifically about the space business, we are involved in satellite communications. We are involved in Earth observation, where my presentation will be mainly about this topic. We are also involved that one of the previous presentations commented about the space surveillance and tracking. This is also a very interesting topic. Indra is leading the development of the Spanish space surveillance and tracking system, SST. The name of this Spanish system is S3T. So we are also involved in this area. Our company is also has a strong involvement in the development of the Galileo and the EGNOS systems in satellite navigation. And finally, in the development of control center solution for the control, for the management and control of the satellites or fleets. And finally, ground station for TTC and for the downlink, data downlink. But today I will mainly focus on Earth observation. Because in Earth observation satellites and the data can be used really for many purposes. In this first slide, we can see the associated workflow to this processing of the Earth observation data taken by satellites that can be combined with other sources, such as data coming from UAVs, hubs, or in situ sensors, open source information, administrative information, like for example, cadastre. So it's very valuable when you can merge all these sources of information. Of course, it is well known that satellites can be combined with other sources. Satellites are becoming cheaper and easier now to be produced and to be launched. So more and more constellations are appearing, and so we have more revisit and imagery and coverage. As an outcome of this new situation, really more images are available from different providers, and the images are becoming cheaper, and even in some cases are free, and are also more accessible. In parallel to this, onboard Earth observation instruments have better performance even with smaller sizes and less weight. To complement this situation, more sophisticated onboard processing systems are being developed, reducing the workload associated to the on-ground treatment. So this is the situation of the availability of space data, of satellite data, and once these data are need to be processed, for this we will use a high-performance geospatial platform that will allow us to generate the development of geospatial solutions. In the platform, we will integrate those specific processing algorithms necessary for development of the different use cases. Different types of applications can be covered. Just to name a few ones: marine resources, disaster risk reduction, urban development, climate change. And depending on the specific case, users can range from governments, citizens, or private companies operating in several sectors. In this presentation, as commented before, I will specifically talk about Earth observation and two specific use cases that are very well known to my company, to Indra, that are the disaster risk reduction and the sustainable tourism. Next slide, please. One of the value-added services that observation can offer is disaster risk reduction, that right now is one of the most used and valued applications. The purpose is reducing risk through geospatial analysis of the possible hazards, evaluating the associated exposure and risk for different types of disasters: floods, landslides, earthquakes, tsunamis. Algorithms based on deep learning techniques are key in the process of analyzing satellite data for both optical and SAR imagery. We can customize the analysis in accordance with the customer requirements, for example, the databases of elemental risk or the vulnerability curves. There are applications in response to different types of hazards. You can see in the slide the first classification into groups: hydro, met, and geohazards, that include, to name a few, tsunami impact assessment, flood hazard mapping, terrain deformation analysis, or wildfire analysis. These products are used in all the disaster risk management cycle, from the prevention and early warning to the post-event recovery and reconstruction analysis. Next slide, please. Okay. In this slide, you can see some examples of Earth observation in the field of this disaster risk reduction domain. In the left side, you can see a flood event. We can calculate, based on, of course, on satellite imagery, the maximum water extent and depth of the floods to identify the most vulnerable areas. So we can simulate even in advance before the crisis happens. We will combine this data with specific algorithms used to automatically identify the buildings, roads, critical infrastructures, or crops. And upon this, we will know a priori which ones are at high risk of being flooded. As we can see in the second picture on the left, where the different levels of risk can be differentiated by colors. In the right side, you can see an example. In this case, is the landslide susceptibility index. We can obtain the most vulnerable areas against a landslide event. So in the image below, you can see the affected buildings classified by risk type. In this example, all of them are classified as medium risk with a yellow color. Next slide, please. Another application that we will review in this case is in the field of tourism, and more specifically the sustainable tourism. This is in trend because of, on one hand, the situation of the COVID-19, and on the other hand, new forms of tourism that are more oriented to our environmentally friendly tourism. So we can say that the last times the way of looking at tourism has changed for many people. Before the current crisis, COVID-19 crisis, pandemic, is in many cases the selection of the touristic destination was made mainly by connectivity or costing reasons. But in the last two holiday seasons, tourism has changed and the demand has increased in rural areas and less touristic coast destinations, avoiding in many cases the most crowded areas. So due to the pandemic, selection of the destination could be made on the basis of social distance, healthcare system, environmental conditions, or terrestrial conditions. Next slide, please. So in a post-COVID scenario, factors as air pollution or population density will be an important aspect in attracting tourism. So post-COVID territorial indicators may become a very suitable element to offer a safe destination. Earth observation can give us information about different indicators for a large area in a quick and easy way. In this slide, we have an example of 3 indicators that have been calculated in 2 different regions. On one hand, in Fuerteventura Island, that is in Spain, and the second case is in the Düsseldorf region in Germany. And the 3 indicators we are calculating are the built-up area, the atmospheric pollution, and the light pollution. Built-up area and population density give us information related to the social distance, and light pollution, atmospheric pollution, or sea pollution can give us information about the environmental conditions. All this information, as well as that information, of course, can be incorporated, can be made available in an app with easy access for tourists, and offering continuously updated information. So continuous monitoring of these conditions is a must. The development of these indicators and their monitoring will be one of the keys to get a more attractive positioning in the touristic sector, that, as you know, is a very competitive sector all over the world, and also for local governments to be able to run a proper territorial management in this new scenario. So, okay, with this, I finish my presentation. Thank you very much, and I pass the word to my colleague. Thank you.
Thank you, Emilio, and thank you all of the speakers today. We had a very interesting discussion ahead of us, and thanks to you. The questions have been popping up, and I would like to start with you, Peter. Thanks for your presentation. And one of the most popular question we have right now at the moment is about what do you think is still missing to build a thriving space industry in Australia? How will collaboration with Europe help?
Thank you very much, Monica, and that's an excellent question. I'll take that in 2 parts. The first one, how do we build a thriving space industry in Australia? Well, we're well on the way. I'd like to emphasise how important it is, the road mapping that Ord is leading at the Space Agency. It's absolutely critical that we see those roadmaps developed for the whole nation, and she's well on the way to doing that. Those roadmaps can be brought together in an overarching picture for the nation, and we should start to envision where we want to be in 10, 15 years' time as a nation, particularly the critical capabilities that are what I would describe as the backbone of the nation. So that's the telecommunications, the precise positioning, and the Earth observation, down to the satellite level that we need as a nation. But there's more. We do that because we produce really high quality information products, as we've already touched on in a number of presentations today. And those very high quality information products are where we really add the value. And the next generation of those information products are going to be in the digital twins and the really complex spatial data and data infrastructures that will enable us to let loose the artificial intelligence on masses of data. And if we can see that as a supply chain from the asset in space all the way through clearly to the information product at the end, then we can give industry much more certainty about where they can make their investment. So that's a brief answer to the first part. In relation to the second part, which is the collaboration with Europe, this is really, really essential. The entrepreneurial skill sets that Europe have, plus the deep business capabilities that exist in Europe, from the small companies all the way through to the very large multinationals, are an ecosystem that Australia would like to emulate. And one of the best ways to emulate is to partner. So partnering with European organisations at the low TRL level, that is the research organisations, all the way through to the operational level, the commercial level, will be critical for Australia. And again, the Space Agency are leading the development of a whole range of agreements and partnering arrangements across Europe, which the rest of Australia is going to benefit from greatly. Thank you.
Thank you, Peter. Our next question is for Odd. When we talk about transformation, space data for industry transformation, especially the notion of developing extended presence in deep space, it's important. So what will be the new benefits of space to our lives on Earth?
That's a great question, and there is a lot of different answers. I think the first thing I will say is a wee story that I discovered when Landsat 9 was launched last week. And it was last week or this week? Last week on Tuesday morning. So Landsat is the first Earth observation satellite. And when we were watching the launch with our colleague in NASA and USGS, they were telling us that when the first picture was taken of the Earth from the moon, you remember that blue Earth that we could see from the moon, this picture that is really showing how small we are. This is where we realized this is interesting to look at the Earth from space. We can see the clouds, we can see characteristics there. And it's apparently at that moment that we decided to start doing Earth observation satellite in space. So that's, I think, an introduction to my answer. Looking at the Earth from space is improving our life on Earth. And then when you go beyond, you're going in an environment where there is no resource, there is no water, there is no oxygen. So everything that we do in the International Space Station, to start with, we have to do it in a sustainable way. And sustainable is a word that you will find in every single roadmap that we are publishing. We are forced to be sustainable in space, and whatever we discover in space to be sustainable, how do we undo our energy? How do we manage our water, this main resource? This is the spin back to Earth. How can we do that on Earth as well? So that's the main spin back that we can draw when we are looking into establishing a presence on the moon and beyond. And you'll see if you read our roadmap, there is always a spin out, but there is also always a spin back as well. And there is a list of all the discoveries and IP that have been discovered in space that we are using today, like the emergency blanket, this foil blanket, emergency blanket you use in disaster to keep warm. This has been developed in space. And there is books listing all this invention that have been discovered in space for space presence that we are using day to day on Earth. I could continue for hours, but I think I will stop there.
Thank you, Odd. Philippe, the next question is for you, and I think we'll cover quite a few students who might be attending our webinar today. It starts like saying that I'm not sure whether I should become a data scientist or a data engineer. There has been always this discussion between these two. So, especially in the space industry, what would you recommend this person to do? What does it take to become a data engineer or a data scientist?
Yeah, that's a really good question, and I think it's an important one as well because they're quite different roles. They obviously both work with data, so there's that big similarity. But I think the question of which one should I do, it depends on you really, because they're quite different. The kind of things. The way I look at them, the way I've seen it in industry as well, is that data engineers traditionally, they're the ones who kind of productionize things. They build the infrastructure and they kind of make a stable platform that businesses can really use to scale from. Whereas data scientists, they're doing a kind of different role where they're exploring, the data that the business has. They're answering questions that the business, want to figure out if they can answer. Testing hypotheses and looking for ways to use data to help the business. So. And then they start to use more advanced tools where they start to look at ML to kind of explore and see what can be found. But both roles are different and contrasting in that way. One's much more like you're building things out, and the other one's more exploring. So I think the question as to which one should I pick kind of depends on what you find more interesting. In terms of demand and in the space industry specifically, I think both have huge demand right now. So you wouldn't find difficulty finding a role. The one that will potentially have more increasing value in the future is data engineering. I've seen is the one which businesses need right now, just because of the way that they have to scale. They need data engineers to build out the infrastructure that they need, and especially this huge reliance on cloud, and that's something that data engineers specialize in. But data science is equally as in demand right now because a lot of people don't have the experience with data to really understand how to query it. What does it take to become one? That's another good question. As you can see, my path wasn't quite clear. I had no idea when I left university that this is what I would be doing. So, but I think kind of the key skill sets that I look at right now is ones that are required for both roles. One is experience with a cloud tool. So looking at trying to pick up experience using Amazon Web Services, Google Cloud Platform, or Microsoft Azure. Those are key because every single business is using one of those three, or if they're not, they will be. So getting experience with one of those is important, and then trying to find a programming language that you can use to manipulate data with, whether that be Python or SQL or Java, something like that, and trying to get a lot of experience with that. And then most importantly, obviously, is finding an example where you can play with that data. If you haven't had any jobs yet in those roles, then try and play around with data. There are loads of really cool tools online like Kaggle, where you can get data sets and start playing around and messing around with data to get your kind of first experience. And then maybe that will give you a better insight for which one you prefer as well. But yeah, it's a good question. I think it's a tough one to answer, but yeah, I'm glad you asked.
Thank you, Felipe. The next question is for Emilio, and it's a very interesting one because with the demand for space engineers growing, how does Indra recruit and retain top talent?
Yes, this is a very good question. Well, I think, of course, there's a lot of pressure because, as you commented, a high demand for space engineers. And I think here is clear how attractive the career you can offer to an engineer is. In this case, the innovation, attractive to get involved in this innovation in space flagship programs, to have to face challenges. I think really this is what we're doing in Indra since 35 years. So we started our activities in mid-80s, and I have to say that this has not changed in this period because, of course, satellites are more complex, but the challenge were there from the beginning. So I think all of this is what makes an attractive career, and I think that this is the we can offer, and we offer to our colleagues, to our engineers, to the new engineers, to the young engineers. Because indeed the space sector is really quite attractive, and if you can participate in these key programs, as for example we are doing in space surveillance and tracking. I commented before, Galileo, Copernicus, EGNOS for the European programs. I think this is really this is a challenge that our engineers are really very keen to work on these classical activities and really working in the state of art in many R&D activities and technological activities.
Thank you, Emilia. Very interesting perspectives of future careers in the space industry. It's very exciting. Odd, I have one for you right now, and I think it's very important, especially for Australians. It's about whether if we have satellites in Australia currently being used to provide internet services.
Thank you, Yano. Good question. The answer is yes. You may have heard of the National Broadband Network, which has been tasked by the government to provide broadband internet to all Australians, following 3 technologies: fiber, copper, and wireless, of course, and satellites for the 3% of Australians who are in remote location. So there's been 2 satellites launched in geostationary orbit called the Sky Musters, and they cover all Australia. There is 101 beams, some small beams that are 20 kilometers diameters, some big beams, 100 kilometers diameters, but the whole Australia is covered. Now, it's geostationary satellite, so you have a tiny wheel lag. I've tested this crazily, and it's only if you know that you're going via the Sky Muster that you realize there is a lag. If you don't know, you don't notice. I guess if you're a gamer, you may notice as well because the response may have a lag, but the service is very good. The other inconvenient is there is a fixed bandwidth allocated by the satellite, so it's a fixed pipe. So it may happen that some beams there are a lot of people living in that beams, so you have to throttle the speed to make sure that everyone access. But we are offering great speeds, and the service is reliable. So the answer is yes. And I used to work on the operation of the Sky Muster, so I can tell you I test everything I do, and it's a great service. And I guess just to finish, there'll be more. The Starlinks are coming, and anybody can choose what's the best. So that's LEO, so the latency is not there, but it's not covering everything just yet. So there'll be more. But whatever you have access to in Europe with the LEO constellation, you will have access to in Australia as well.
Great news, Odd. These are really great news. I have another question here, and it probably is for you, Peter. It's about which possibilities exist for startups. And I believe the person is thinking about European startups to participate in Australia.
Thank you. That is a very good question. What SmartSat does with startups is that it allows startups to join SmartSat for no cost. For at least the first year. They will formally join via a startup parent company that has its own board that provides a strong voice into the governance of SmartSat, representing the startups and indicating what they need to grow, so that the investments that SmartSat makes are strongly oriented towards helping those startups develop their capabilities. The other thing that SmartSat does to help, of course, is to bring to bear capital. And SmartSat has formed a grouping of venture capital organisations and helps when the startups are developing their intellectual capabilities, their products and services. They can be pre-qualified with SmartSat's assistance and then matched with the interests of the venture capital organisations to see whether there is a pairing possible. Because we know startups are led by beaut entrepreneurs who are very time poor. So anything that can assist them in their risk management is a high priority for SmartSat to assist with. Thank you.
Thank you, Peter. The next question is for you, Philippe. Is, in your opinion, how universities could be more prepared for producing data scientists and data engineers based on your experience?
That's a good question and a tough one as well, because it's one that we ask ourselves, in every business I've worked in, because one of the problems that we have, obviously, is when we hire new people, well, graduates coming fresh, is that they're quite green, so they don't often have any experience in the stuff we're doing, which it can be kind of shocking sometimes. Not shocking in the sense we expect it, but it's it means that hiring graduates can be quite a big investment for these businesses, because it means having to teach them a lot of the skills that they require. Thankfully, it's not soft skills that are a problem. Obviously, that stuff is always coming out great from university, but it's the technical things that seem to be lacking. And at least in my degree, what I did and what it's like in the UK. But one of the things I've been interested to see if business or universities can start to do is to try and get more feedback from businesses to see what's the current tech stack that you guys are using, and trying to introduce courses around that, and then also to try and reintroduce or try and make it more popular to do year in industries and like work placements, where you can actually, students can actually get a feel for what it is without a cost to the business. And understand more about the skills that they should be looking to learn at university. But yeah, I think it's a good question. It's a tough one because there's no easy answer. But yeah, good question.
Thank you, Felipe. And I have the last question to you, Emilio. Where do you think Indra will be in the next 5 years? Where do you see Indra evolving to new applications, new strategies?
Well, this is also a pretty good question. Clearly, there are 2 or 3 areas where really future points. On one hand, Indra is working now, has a joint initiative with NAIRE, that is the Spanish air navigation service provider, to develop constellation that will provide space-based CNS services. This is mainly for the ATM market. So this is say a strong bet from our company for these services, and we will develop a proprietary constellation with the aim to offer services in this initiative that, as I've said, is not only Indra, but together with NAIRE. We also think that the space traffic management will be a key for the next years. You commented before the congestion of the LEO orbits, and I think really space traffic management will be it's a must for say all these operators, all the people who are involved in the space business, and of course we'll have something to say there for both the data supply with the ground-based radars, and also for the services and applications. And finally, there are new initiatives as GovSatcom in Europe. I mean that having secure and full coverage satellite communications available in Europe. GovSatcom seems to be a strong program from the Commission that will be a new flagship together with Leo, Agnos, and Copernicus. And I'm also convinced that we will have also a strong involvement in these activities. This is in general about programs. Of course, about technology runs very fast. And now probably you talk about artificial intelligence basically you're not talking about the future, you're talking about the present. But I think clearly this is something that more and more we are including in our operations, in our services for space for SSA, I mean for STM, and also for Earth observation, and even for maintenance activities. So more or less these are the main areas at technological level, at program level, that I think we will get involved in the coming years.
Thank you, Emilio, and I would like to thank our speakers as well as our fantastic audience. We have such interesting questions today and comments throughout the event. I would also like to thank you to RMIT Europe team for making today's event happen. It was fantastic work in the background scenes here to run this webinar. So now I just would like to ask you to please take a moment to share your feedback on today's webinar using the link you will soon see in the Q&A. Here you can also register to receive a certificate of attendance. Thank you all once again for joining us today.